All right, before we start implementing or writing any code, let's first understand what binary search actually is. Binary search actually is a searching algorithm that works only on a sorted array. It finds an element by repeatedly dividing the search space into halves. So let us first understand this with an example. So suppose we have an array, say 2, 5, 8, 12, 16, 23, 38, 56, 72, and 91. So we have this array and we want to find the element 23. So target will be 23. Okay. One way is the linear search. So we got to check each and every element one by one, but that is slow for large arrays. So that is kind of eliminated. Now binary search takes advantage of the sorting and directly checks the middle element. So what is the middle element here? Let's index them. 2, 3, 4, 5, 6, 7, 8, 9. So mid will be 16 because we are considering the first middle element here. So we first go to the middle element of the array and we compare the target with the middle element. So this is the target and we compare it with the middle element. And since 23 is greater than 16, we can ignore the left half. That is, we can just remove this part away. Okay. Now we are left with 23, 38, 56, 72, and 91. This is the key idea. So the thing is we discard half of the array in one step. Now even here, we go to the middle of the remaining array. So the middle will be 56 and we compare it with the target. And since 23 is smaller than 56, we discard the right half this time. So the right half will be, this part will be discarded. So we are kind of left with 23 and 38. Okay. Observe that our search space keeps shrinking and eventually we'll find the target element. Now the target element is 23 and which is found in our case. Because we keep halving the array, binary search kind of runs in logarithmic time. So the time complexity will be big O of log n. And where can we use binary search? So it works only when the data is sorted and we can directly access elements by index. So the conditions will be first array or any data should be first sorted and we should have fast random access. Okay, fast random access. Binary search isn't just an interview concept, it is actually used everywhere from searching in sorted arrays and finding first or last occurrences to real world systems like database indexing, version control tools like git bisect, and even optimization problems in competitive programming. Now that we understood what binary search actually is, let us see how to implement it in code via both iterative and recursive approach. Let's look at the coding part now. All right, let's quickly code the iterative approach for binary search. So we have a function that takes a sorted array and the key we want to search for. Now let us start by initializing the pointers. Low is 0 and high is len of array minus 1. Okay, so low points to the start of the array and high points to the end of the array. Now we got to start the binary search loop while low is less than or equals to high. That is, we keep searching as long as the search space is still valid. The next step will be to find the middle element. So mid is low plus high minus low by 2. So here in this step we are calculating the middle of the index, and note that mid is an index, not a value. Mid is an index, but array of mid is the value of the array at that index. Okay, so now let's compare the middle element. If array of mid is equals to k, if the middle element is equal to the key, then we found the element, so we return mid. Okay, because we found the element, so we return the index immediately. For suppose if a middle element is smaller than the key, that is array of mid in any case is smaller than the key or the target, then we discard the left half by moving forward, that is low is mid plus 1. Okay, and otherwise the key must be on the left half, so else high is mid minus 1, that is we discard the right half. Okay, and if at all the element is not found, then we simply return minus 1. If the loop ends, the element is not present in the array, so we return minus 1. Now let's go ahead and run the code. As you can see, if element exists, we are returning the index, else we are simply returning minus 1. Here are the test cases for your reference. Now let's quickly look into the recursive approach. Alright, so here we've defined a recursive binary search function. Along with array and key, we also pass low and high indexes. So we are passing the high and low indexes down in the driver code itself. So we need not initialize it as we did for the earlier approach. Now coming to the base case, which is the most important case, if for suppose uh, if low is greater than high, we return -1. Why are we doing this? Because if low becomes greater than high, the search space is exhausted, so the element does not exist. Okay, now we got to calculate the mid. So mid is low plus high minus low by 2. We calculate the middle index safely. Again, mid is an index and not a value. Okay, now if array of mid is for suppose equals to k, then we return mid, because if the middle element matches the key, then we return the index immediately. Now if that's not the case, if array of mid for suppose is greater than k, then we return binary search of array comma low comma mid -1 comma k. Why are we doing this? If middle element in any case is greater than the key must be in the left half. So we recursively search from low to mid -1. All right. Now, if that's not the case, we in the case where we got a search to the right half, else we return binary search of array comma mid +1 high and k. The key, if it is in the right half, we recursively search from mid +1 to high. Okay, now let's go ahead and run the code. As we can see, we got the same output as the earlier method. The point to be noted here is that recursive binary search also runs in big O of login time, but it also uses big O of login space due to recursion stack. And the iterative binary search is usually preferred in interviews because it achieves the same time complexity with constant space. Thanks for watching.